Hello, welcome to the video. In this lesson, we're going to be looking at section 5.3, where we're going to be solving systems of linear equations by elimination. This is the second way that we can solve a system algebraically. 5.2, we looked at solving systems by substitution. That is the first way you could solve it algebraically. So now the second way is through elimination. Here is the steps on what they want you to do in order to solve it by elimination. Just like with substitution, we were substituting a value in for x and y. In order to solve here, we are simply going to eliminate one of the variables in order to solve for the other. So in the first step here, it says you are going to multiply, if necessary, one or both equations by a constant, so by a number. So at least one pair of like terms has the same or opposite coefficients. Now, before you do that, I would suggest to make sure that each of the equations in the system are written in standard form. I spelled that wrong. The ax plus by equals c form. Have x be your first term, y be your second term, and it's equal to a constant value. Then from there, we can add or subtract the equations to eliminate one of the variables. Then you're going to solve for the variable that's left over. And then finally, you're going to substitute in that value in for whatever it is to one of the other original equations to get the other variable. So here is an example of how they want us to solve a system by elimination. Normally, between the two, it really doesn't matter if you use substitution or elimination, you will get the same answer. But what I would suggest is anytime that you can't none of your variables have a coefficient of 1 in front of it, that is where it's optimal to use substitution. But when it's something else other than 1, it is optimal to use elimination. So if I look here, equation 1's already in standard form, 3x plus 2y equals 4, and equation 2 is also in standard form, 3x minus 2y is equal to negative 4. All right, now what I notice is this. Look here at this pairing of variables. I have a positive 2y and a negative 2y. I have what are called opposite coefficients of each other. Since I already have an opposite coefficient of that particular variable, I don't need to multiply any one value or any one equation in order to eliminate one of the variables. I already have all the necessary things I need to eliminate the variable y. So what this does is it allows you to just add everything that is like terms. So 3x plus 3x is 6x. Positive 2y plus a negative 2y is actually going to be 0. So this is where the elimination comes in, so that gets canceled. It is now going to be equal to 4 plus a negative 4, so that is 0. So now I have 6x is equal to 0. From here, I divide 6 to both sides, so x is equal to 0 in this particular instance. So now what you're going to do to solve for y is you're going to pick one of these two equations to help you solve for y. I'm going to choose the first one just because y is already positive. So now I have, so when I go over here, this is going to be 3 times it by 0 plus 2y is equal to 4. 3 times 0 is 0, so it's essentially 2y is equal to 4. Y will be equal to 2. So my ordered pair in this particular situation is 0, comma 2. Now looking at this one, it is still both of them are in standard form, but I look here, I have a negative 10, negative 5. Between those, they're not the same, and I got 3 and I got negative 6. Neither of those are the same. So this is where it becomes necessary to multiply one or both of the equations. Now, what I'm going to choose to do is I am going to choose to eliminate the variables that already have opposite signs. So with X, they're both negative. They're not opposite signs. But with Y, one's positive and one's negative. So from there, I am going to just simply choose to multiply uh, one of the two equations to help me eliminate Y. Could you use it to eliminate X? The answer is yes. But this is just my choice at this time. So I am going to just rewrite out the equations here. And looking at this negative 6 and looking at the positive 3. 3 can actually go into 6 if I multiply 3 by 2. But what I have to do is I have to multiply the entire equation by 2 in order to keep it balanced. So when I do that, I distribute the 2 to every term in that first equation, which now becomes negative 20x plus 6y is equal to 2. And then I'm just going to rewrite the second equation. So now I'm just going to add them. This gets canceled because they eliminate, because one's a positive 6, one's a negative 6. Negative 20x plus negative 5x is negative 25x. And it's going to be equal to 2 plus 23, which is 25. I divide negative 25 to both sides. X will give me a negative 1. Now that I have that, now I have to choose one of the two equations in order to solve for y. I'm just going to choose this one because y is positive 3. Nothing wrong with that. If you choose equation 2, you'll still get the same answer. From here, I got negative 10 times it by negative 1 plus 3y is equal to 1. From here, multiplying those, I get positive 10 plus 3y is equal to 1. So I subtract 10 to both sides, cross out, I get 3y is equal to a negative 9. And then I divide 3 to both sides, so y is equal to negative 3. So my ordered pair here is negative 1 comma negative 3. Finally, we have a story problem here, and it says a business with 2 locations buys 7 large delivery vans and 5 small delivery vans. Location A receives 5 large vans and 2 small vans for a total cost of $235,000. Location B receives 2 large vans and 3 small vans, and it costs $160,000. They want to know what is the cost of each type of van. So what we can do is we have to denote a variable to a particular unknown. So we'll say X and we'll say Y. Well, what is X going to be equal to and what is Y going to be equal to? Let's say that X represents the cost of one large van, and Y represents the cost of one small van. So because we have two unknowns, we don't know the cost of the large van, we don't know the cost of the small van, we need to write two equations in order to solve this. What helps us is the different locations. Here it says that location A received 5 large vans, so we'll say that 5x plus 2y will be equal to 235,000. For location B, it says that we have 2 large vans, so it's going to be what? 2x plus 3y will be equal to 160,000. All right, so now in this particular one, looking at this system, I have 5 and I have 2 with x, and I have 2 and I have 3 with y. There is nothing I can easily multiply by 2 to get me 5, and there's nothing I can easily multiply 2 to get 3. So this would be a particular situation where we are going to have to multiply by both equations. And since everything's positive, one's going to be a negative number that gets multiplied, and one's going to be a positive number that gets multiplied. So what I'm going to do is, looking at both of these equations, I simply have to choose which variable I want to eliminate. And it really does not matter which one you choose. I am going to choose to eliminate, let's eliminate x from here. So if I choose to eliminate x, what I'm going to do is I'm going to multiply the top equation by 2. Why 2? Because that's the number we have here. The number I'm going to multiply to the bottom equation is not just 5, but it's going to be a negative 5. The reason why it has to be negative is because in order to eliminate that x, one's got to be positive and one's got to be negative. You could have easily have multiplied the top one by a negative 2. That's just my choice at this time. So once I distribute, I get 2, so that gives me 10x plus 4y is equal to, what, 470,000. Then this is going to give me, on the bottom equation, I'm going to get negative 10x minus 15y is going to be equal to a negative, so I got 160,000 times it by a negative 5. I get negative 800,000. So this allows me to eliminate that y. 4 plus negative 15 gives me a negative 11y. And negative 800,000 plus 470,000 gives me a negative 330,000. So to get the cost for one small van, because that was y, I'm going to divide it by a negative 11. So that means that the small van cost $30,000. So $30,000 is that cost. I'm just going to put $30,000 right here. Let's see what it's going to cost for the large van. So I'm just going to pick. I'll just pick this one. So 2 times x plus 3 times it by 30,000, because that's my value of y, is going to be equal to 160,000. So 30,000 times 2 is 60,000. So I got 2x plus 60,000 is equal to 160,000. 160,000 subtracted by 60,000. That gives me 100,000. Divide that by 2. That means that x is going to be equal to $50,000. So the large van is $50,000 and the small van is $30,000. And that is being able to solve systems of linear equations by elimination. Hope this helps. Till next time.